guys, welcome to Distance Learning with Lee, where I make learning mathematics super easy, right? So guys, with this video tutorial, if you watched my previous video tutorial where I was going through the proportionality theorem, I was showing you guys how you basically derive the proportionality theorem, right? Where you have AD over DB, which is equal to AE over EC, right? So in the previous video tutorial, right, I was showing you guys how we derive this equation, right? So if you haven't watched that video tutorial, guys, please make sure that you watch that video tutorial, guys. It is very informative, and it also shows you guys the steps that you guys are supposed to follow to help you prove the proportionality theorem, right? So if you watched that video tutorial, in this video tutorial, I'm going to be taking you guys through the an example that involves the proportionality theorem, just to help us with the application of the proportionality theorem. All right, so let us get started with this example. Alright guys, and before we get started, please make sure that you are subscribed to the channel. Please make sure that you like this video, give this video a huge thumbs up because it helps the channel grow. And also please make sure that you click on the notification bell so that you get notified every time I upload a new video tutorial, right? And please share the channel with your friends that are also struggling, or friends that just want to better their mathematics marks, guys, right? So anyway guys, without any further ado, let's get started with the video tutorial. Alright guys, so we're going to be going through example 1, and this example tackles the proportionality theorem. It just helps with the application of the proportionality theorem. And like I said, before you watch this video tutorial, please make sure that you've watched this video tutorial where I've gone through the proof of the proportionality theorem and just explaining what the proportionality theorem is, right? So then guys, copy down this question, draw the diagram, copy down the questions, right? And let us get started. So in the diagram, RF, we're told that RF is parallel to KG, and we are also told that ED is parallel to KH, right? We are told that RH is equal to 3 units. We are told that RK is equal to 9 units. We are told that HF is equal to 2 units, and we are told that the ratio of GE to EK is 1 and 3. So GE is that one, is 1 unit, and EK is 3 units, right? And we need to calculate, stating reasons, the length of FG and also the length of FD. You know, this question can be such a headache. It can be so stressful if you do not know your proportionality theorem. But if you've gone through the proportionality theorem and you know what the proportionality theorem states, then you will be able to approach this question. Right, so what does the proportionality theorem state again, guys? Right, so the proportionality theorem states that if a line is drawn parallel to one side of a triangle, right? So this is the line. RF is drawn parallel to this side of the triangle, then that line divides the other two sides in the same proportion. We also have a line ED, and that line is also drawn parallel to this triangle, right? And this line divides the other sides of the triangle in the same proportion, right? So what does it mean? How can we use this theorem to help us calculate the length of FG, right? So firstly, guys, we're going to highlight what we are required to calculate, right? So this is our FG here, okay? And we're required to calculate the length of FG. Guys, for 4.1, this one is very simple because we simply just apply the proportionality theorem to help us analyze this question, right? So what does the proportionality theorem state? Okay, the proportionality theorem states then that HR over RK is equal to HF over FG. So then we're going to write the proportions, which is HR over RK, and that is equal to HF F over FG. Okay, so like I mentioned, guys, in this question, we are required to calculate the length of our FG, right? So we're required to calculate the length of our FG. So basically what I've done is I've redrawn the triangle to just help us see what is going on, because I don't want to be going back and forth, right? And then, guys, so that is the proportionality theorem, right? HR over RK is equal to HF over FG, right? Okay, so from here, once we've basically got that first step down, right? So that is the first step that we have down. We're basically going to substitute all the values that we have. We've got the value of HR, which is 3. We've got the value of RK, which is 9. We've got the value of HF, which is 2. And we want the value of FG, right? So from here, guys, after we've substituted all our values, we will just need to make FG the subject of the formula, and it becomes easy peasy lemon squeezy, right? And then we can just get the value of our FG, right? So then let us just do that. Okay, let us substitute all the values. So we said HR is 3, right? We said that RK is 9, which is equal to, we said HF is 2 over, what is our FG? Our FG is what we are looking for. All right. Then from here, guys, we simply make FG the subject of the formula. So what I'm thinking is that I can just multiply it by FG on both sides. So I can just have FG on its own on this side, right? So if I multiply it by FG, you're going to have FG multiplied by 3 over 9, which is equal to 2, right? And then if I also multiplied by 9 over 3, right? If I multiply by 9 over 3, so that the 3 and the 3 cancel, 9 and the 9 cancel, right? And what you do on the left hand side, you do on the right hand side, which is multiplied by 9 over 3. We find that your FG is equal to 2 multiplied by 9 over 3. So what is our answer? It is equal to 6 units. Okay, so the distance from our F, to our G, that distance there is equal to 6 units. Okay, so we found that our FG is equal to 6 units. Yeah, so now 4.2, we need to calculate stating reasons, right? The length of FD. Okay, guys, I actually forgot to just give you guys the reasons for why we said that HR over RK is equal to HF over FG, right? So the reason that you can give for that, or for making that claim, is because that we know that RF is parallel to kg. Okay, RF is parallel to kg, or you can say proportionality theorem. Okay, so that is the reason that you can give, right? And then now for the third one is we need to calculate the length of FD. So what is that length? Where is that length? Right? Where is that length? Right? So let me just highlight that for you guys. We have to calculate FD. It's this one here, that length there, right? So I'm going to redraw the triangle quickly so that we see what we're working with and how we can use that to help us answer our question. All right, so let us just label everything that we have here. We've got H, we've got F, we've got G, we've got E, we've got K, right? And then we also had another line there. I'm just going to make it in blue from there to there, right? And this was called our RF. This is not F, this is D. Okay, and then from the previous calculation, guys, we already got what the size of our FG is, right? The length actually of our FG, and we found that from the distance from there to there is equal to 6 units. So we're going to put that down. Okay, and then we're just going to fill in the other information that we were given initially. So that is 2, that is 3, that is 9, that is 3, that is 1, Okay, and we are trying to calculate that FD there. I've done it in black, right? So that is the size or the length that we are trying to calculate there, that FD, right? So guys, like I said, we are dealing with the proportionality theorem because we've got a side that is parallel to another side of a triangle. It's still the same story even with this question, right? We've got a side here that is parallel to this side here. So our ED is parallel to our HK. How can we start off this question, right? So the first thing we need to do is we need to state that proportionality theorem, right? And the proportionality theorem states that our GE over EK is equal to GD over DH, right? Why am I choosing to look at this triangle like this now, right? It's because we're trying to find a way that we will be able to find that FD there, but it will make sense as I go along with the question, right? So let's just first start off by writing the proportionality theorem. And the proportionality theorem in this case for this triangle is saying that GE over EK is equal to GD over DH, right? And the reason that you can give for this is ED is parallel to KH, or you can say proportionality theorem. Okay, and then from here, guys, what do we know, right? From here, it's very easy because we already know the value of our GE, which is 1. We already know the value of our EK, which is 3. But yeah, this is where it gets a bit complicated. GD, we don't know what GD is. But what does GD comprise of, or what can help us get GD? So that is the question that you should ask yourself, right? Same with DH, right? So that is our DH. We don't know what the length of our DH is, right? But how can I get the length of DH? The length of DH can be obtained by saying DF plus FH, right? We don't know what the length of GD is, right? From G to D, right? But we can get the length of GD by saying FG minus FD to get that length there, right? But it will make sense after I show you guys with the calculations, okay? Okay, so like I said, we can just simply substitute the value of GE, and we found that the value of GE is equal to 1, okay? So it's that value there, and it's equal to 1 over, what is our value of our EK? It's 3, right? Which is equal to, what is GD, right? Where is GD, right? So that is our GD there. But let us first see here. We found that FG, that is FG, right? And what is FG composed of? FG is composed of FD plus DG, right? So I'm just going to write that equation here on the side. FG is equal to FD plus DG, right? But then in this formula, we want to find the value of GD, right? So what do we need to do? We just need to make that GD the subject of the formula, or isolate it, right? So that we have the formula that will help us get the value of our GD. Okay, so when we isolate our GD, we'll find that FG minus, because this is going to go to that side, FD is equal to GD, right? I've basically swapped these around. Okay, so we can simply substitute these values into our formula here at the top for GD. So when we see GD, we're going to say FG. We're going to say FG minus FD. Okay, all over. What is DH, right? So we look at our DH, right? So that is our DH there. Okay, that is the DH. And what does DH composed of, or what makes up DH? So DH is made up of your FD plus your HF. Okay, so you're gonna say DH is equal to HF, right, is that HF there plus that FD. And we know from here, guys, that we are trying to find what is the value of our FD, right? So from DH, we're going to simply take this equation and we're going to substitute it into this formula and we're going to work with it to find our FD. Okay, and then from here, guys, we're going to substitute the other known values that we have. What is our FG? Our FG, we found that to be 6 units. So where we see FG, we're going to put 6 units. Minus FD is what we're looking for. All over HF. So what is our HF? So we go to HF. HF is equal to 2 plus your FD, which is what we are looking for. Okay, from here, guys, we are just going to cross multiply, right, so that we get rid of the denominators, right? So we're gonna cross multiply, right? Okay, and you'll have 1 multiplied by 2 plus FD, which is equal to 3 multiplied by 6 minus FD, right? So you're gonna remove your brackets, so it's gonna be 2 plus FD is equal to 3 times 6 is 18 minus 3 times minus FD is minus 3 FD. And then here, guys, oh gosh, like we are seeing the light. Everything is starting to look very simple. We are really just gonna add all your like terms, right? Add all your like terms. So it's gonna be plus the FD here plus your 3 FD, because that moves to that side there, which is equal to 18 minus 2, right? FD plus 3 FD is equal to 4 FD, which is equal to 18 minus 2 is 16. And if you divide by 4 on both sides, right, you find that your FD is equal to 4 units, right? And from here, guys, we are simply done. We've answered our questions. We are getting distinctions. We are happy, right? We simply gonna put that there. Okay, we found that your FD is equal to 4 units. Okay, guys, and we are done with the question, right? So guys, from here, I think the take from this question is that you need to know what the proportionality theorem is, how you even start with analyzing your question when you apply your proportionality theorem, right? And like I mentioned, please make sure that you watch this video where I've gone through what the proportionality theorem is and how it is applied, right? So then from there, guys, if we know that we are working or dealing with the proportionality theorem, you look at what you are asked to find, right, which is FD, and then you see how you can work with the proportionality theorem to help you find that value, right? So in this case, we are looking for FG, right? So then we could just do HR over RK, which is equal to HF over FG, right? And then from there, guys, I showed you that it just becomes very simple, right? Because if you say HR over RK, which is equal to HF over FG, you substitute the values that are given. We were given HR, we were given RK, we were given HF, right? And then from there, we just simply looking for FG. So with this particular problem, it is very simple. It is literally substituting what you were given to solve for FG, right? But then now it started getting complicated when we got to the second question where they asked us to find FD. Okay, and this question wants us to look at this triangle in a different angle, right? So if we just focus on the triangle GKH, that whole triangle there, and just focus on the parallel line DE, we first state the proportionality theorem, which is GE over EK is equal to GD over DH. From there, guys, it just becomes very, very easy, because all we need to do is we need to think, what are we asked for, right? And then from there, on the right hand side, what did we see? GD. We need GD, right? And that is our GD. Okay, but it was going to be hard for us to just substitute values because we don't know what the GD is. But we can break up the GD, right? We can break up the GD. right? Because we saw that, okay, when we found the value of our length FG, the FG consists of FD plus GD, right? So we said FG is equal to FD plus DG, right? From there, we were going to be able to isolate our GD and make it the subject of the formula to substitute it into our equation. And the denominator DH, how do you get our DH? We also saw that we don't really have the length of DH, but which length do we have? We have the length of HD, right? And what is the length? The length of HD? The length of HD consists of HF plus FD. So that is what we did, right? And we substitute that DH, that new equation of DH, into our formula, and from there it was just substituting our GE, substituting our EK, right? And then also substituting the known values of our FG and HF, right? And then from there, guys, we simply just cross multiplied, right, to get rid of the denominators, and we found that our FD is equal to 4 units, right? I hope I made this question simple and straightforward for you guys to understand. Please don't forget to just comment on the comment section and tell me how you found the video. Did I make it simple for you to understand? Were there certain concepts that you are not understanding during the video, guys? Please make sure that you engage with me and tell me how you found the video. But then, guys, for today's video tutorial, that is it, right, on going through an application question of the proportionality theorem. Okay, guys, so yeah, guys, that is it, and I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.